Okay, here we're going to look at functions as graphs. So we're going to look at getting points on graphs and then also finding functions to represent those points. So there are various ways to represent a function. We have tables, inputs or ordered pairs, input outputs, ordered pairs, and then we can place these on the graph. Remember, this horizontal axis is the x-axis, and then the vertical axis is the y-axis. Y goes to the sky. The horizontal axis is the input. The vertical axis is the output. Excuse me. So we're going to create a table and graph the function y is equal to 2x minus 3, and then we're only using 2, 3, 4, and let's make this 5 for the domain. So I'll create my table. I'm going to make this one vertical. And we will use 2, 3, 4, and then 5. And then 2x minus 3, you might need to do a little work on the side here. But we're going to take 2 and plug it in for x. And so this gives me y is equal to 1. 4 minus 3, we'll go ahead and write that out in the first one, is equal to 1. And then you would do this for each point. So take it, 3 times 2 is 6, minus 3 is 3. 4 times 2 is 8, minus 3 is 5. And you might see a pattern here, which is good. As the x's go up 1, the y's are going up 2. It's kind of interesting. And so you can predict that to be 7. But let's plug it in just to make sure. 5 times 2 is 10, minus 3 is 7. Okay, that's good. Okay, then we need to graph this function. We're going to make this 0, 0 down here. So we'll just put an O for the origin. And this is my x, and this is my y-axis. So 2, 1 means to go over 2. If you write these as an ordered pair or a point you plot, it would look like this. And so this means to go over 2 and up 1. So we count over 2 and up 1, and there's a point. That's not a point down there at 0, 0. Over 3 and up 3 is here. 4, 5 is here, and then 5, 7 would be here. Now we're not connecting these as a line, if that's something you've done before, because our domain is only 2, 3, 4, and 5. If I connected them, then my domain would be everything in between. It'd be like 2.1, 2.2, everything in between. So it's just those points that you're plotting. Okay, let's apply this a little bit. So this table specifically shows profit in the year from 2000 to 2004. And then T is the years since 2000. So let's label this as years for the independent variable. And then we're going to spread these out a little bit. Let's make this 0, and then we'll do 1 right here, 2, 3, and 4. And then if you look at the profit, it's in thousands of dollars. Let's put years. Let's be more specific. So we'll say in thousands here. And then years, and then since 2000. So our profit kind of has some kind of difficult points to plot. We have 19.5, 20.3, and so on. And so I don't really want to start here at 0. Although you could, it would just be kind of problematic. So let's label this down here as 19. And then to make sure, let's see, we need to get all the way to 22.7, so about 23. Let's just count by maybe like 0.2. So then 19, 2, 4, 6, 8, and then this would be 20. and then 2, 4, 6, 8. This would be 21. 2, 4, 6, 8, 22, and I need to get 22.7, which I'm going to be off my graph, but that's okay. And so the 2, 4, 6, 8, we'll make that up there. So we'll kind of add some points. So this would be 22.8. So, and when you're having to make these graphs with kind of these weird scales or kind of specific scales, do the best you can by hand. You won't be penalized if you go off the graph like this or something like that. Okay, so then just plot each point, 0 and 19.5. So 0 is somewhere at 19.5. I went by 2, so 19.2, 19.4, 19.5 is right there. And then 1 and 20.3, so 1 and 20.3, this is 20.2, so 20.3 is in between there. 2 and 22.7, that's all the way off my grid, but still on my graph. My highest point was 22.8, so we'll put it about right there. 3 and 21.1, so that's just above 21 a little bit. And then 4 and 21.8. So 4 and then 2, 4, 6. 2, 4, 6, 8. I put that in the one in the wrong spot. This is 22. 22 is up here. Counted wrong on all of them. 2, 4, 6. This is 21 right here. So let's move that up to here. Twenty-two is up there. Okay, so there, those points, and I counted incorrectly. Sorry about that. But there, I think I got them fixed. So there's these points that represent this function. Okay, we can write a rule from the function represented by the graph. And when you do this, I would say start by just listing the points. Let's turn this graph into a table. And then when you get good at that, you can stop doing that. But so this point's 1, 0. This point's 3, 2. This point's 5, 4. And this point is 7, 6. So then maybe you can start seeing a connection here. So we're taking the x value and subtracting 1 both time, or each time. So this would be y is equal to x minus 1. Okay, make sure you pause the video, try the rest of them, at least list the points out, and then see how you do with the function rule as well. Oh, we got to state the domain and range. So domain is 1, 3, 5, and 7. And then the range is 0, 2, 4, and 6. Okay, on this next one, I'm going to list these horizontally. Let's go ahead and box that in. So we have 0, 5, and then 1, 4, and then 2, 3, and then let's see, 3, 2, and 4, 1. Since you're going down 1 each time, you might want to think about where you're starting. So your initial value, you start at 5, and you're subtracting the x value. So it's 5 minus 0 is 5. 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 3 is 2. And 5 minus 4 is 1. So when you have this downward trend, you're going to subtract an x value or a multiple of x. So this would be y is equal to 5 minus x. Our domain, we'll just use D for domain, is 0, 1, 2, 3, and 4. And our range is 5, 4, 3, 2, and 1. And you should probably actually better to write 1, 2, 3, 4, 5 when you list these, even though that's not the order they kind of appear there. Okay, and then last one here, I'm going to put the table over here. So we start at 110, and then pay attention to the scale. It's by 5, so it goes up to 2, and then 15 would be right here. 320, and then 425. So here you can see we're going, well, you're going up by 5 each time. So this pattern or this function rule is a little bit more difficult to see. But what's happening, you can kind of use this idea that you're going up by 5 each time to help you out. So that means you're going to multiply by 5. So I'm going to take my input and multiply it by 5. So 1 times 5 is 5, and then add 5 to it is 10. 2 times 5 is 10, and add 5 to it, and I get 15. So it's 5x plus 5 for the function rule there. And then my domain is 1, 2, 3, and 4. And my range is 10, 15, 20, and 25. And I ran out of room there. Okay, make sure you pause the video, give this one a try, this word problem, read through it, as it's important to practice your reading and see if you can interpret what the problem is asking you to do. This says the graph shows the average number of video rentals per month at a video store for the years 2000 to 2006. Okay, so that's my independent variable. Oh, and that's what we got to identify. So let's go ahead. So we'll just say years since 2000 is the independent variable. And then the average number of video rentals per month is the dependent variable. So we'll say average rentals per month is the dependent variable. Describe how the average number of rentals changed over the period shown, and how would you expect the average number of rentals in 2006 to compare to 2007? So here, there's not like an exact amount, right? Like it's not a straight line, but you can see that it's going, or you should be able to see that it's going down. Like we were, maybe 380, and then we're at 350. Now they're down below 300. And so the rentals are falling. So describe how the average number of rentals changed. We'll say the number of rentals decreases each year. And how would you expect the number of rentals in 2006 to compare to the number in 2007? We'll say 2007 should have fewer rentals. And this, you can also tell by the age, the years here, but this is kind of older problem, right? So people used to go into a video store and actually rent a movie. So you'd physically drive to a store, rent a movie or two if you were lucky, and then take them back to your house and watch them and then return them within a few days. And that is no longer a thing. So 2020, it is no more. Okay, as always, please ask questions if you have any.